Okay, just going to look at division of a complex number. So say we have 2 plus I and we had it on 2 minus I. Okay, now I just want to remind you of what happens with a surd. With a surd. So we had 2 plus 3 root 2 over 2 minus 3 root 2. And what we want to do, to simplify that, we want to make the bottom a rational number. So in order to make that a rational number, you have to actually multiply by the conjugate surd. So 2 plus 3 root 2 over 2 minus 3 root 2. The conjugate would be 2 plus 3 root 2. You do that on the bottom, because what you're basically forming is the difference of two squares. And when you form the difference of two squares, you got a minus b, a plus b, you end up with a squared minus b squared. So when you square a surd, like when you square that b squared there, you end up with, on the bottom, 2 squared minus 3 root 2 squared. So when you square a surd, like root 2 squared, you get root 2 times root 2, which is root 4, which is 2. So the square root actually disappears. So the square root and the square cancel each other out. That's why doing it by the difference of two squares removes the surd from the bottom. So what you do to the bottom, you do to the top. Now on the top, that's basically a perfect square because there's two of the same things. So it's 2 plus root 3, 2, all squared. So it'll be, the quick way would be to square the first, plus 2 times 3 root 2, plus 3 root 2 squared. Because this one, because they're the same sign in the middle, it won't cancel the middle terms out, unlike the bottom one, where it will, because you've got a minus 6 root 2 and you've got a plus 6 root 2. So it's going to be 4 plus, on the bottom you'll have 4 minus 9 times 2, and just to, etc. Then you go 4 3s are 12 root 2 plus 9 times 2, which is 18, over 4 minus 18, so you get 22 plus 12 root 2 over minus 14. You can change the sign on the top, over 14, and then there is a factor of 2. So let's just take the factor of 2 out. That goes into that 7, and that's your answer. So we're going to apply the same sort of strategy to complex numbers. Okay, so if you have 2 plus 3i and 2 minus 3i, in order to simplify that and put it into the form, to simplify it, you really want it in the form of a plus bi. So if you multiply the bottom by 2 plus 3i and the top by 2 plus 3i, that's multiplying by the conjugate surd, then on the bottom you will get 2 squared minus 3i squared. And you'll find the square will cancel out. The i's will cancel this because the I will cancel out when you square it, because I squared is just minus 1. And the middle terms here, so you get minus 6i plus 6i, they cancel out. So on the top you have 2 2s are 4 plus 6i, it's just a perfect square, plus 6i plus 3i squared. So it'll be 4 plus 12i minus 9 over 4 minus 9 times I squared. I squared's minus 1. 4 minus 9 is minus 5 plus 12i, and on the bottom you get 4 minus 9. So it's minus 5 plus 12i on minus 5. If you don't like the minus on the bottom, just change the sign on the top, because it's much neater to have a positive on the bottom, to have a positive denominator. And if you then had to put that into the form of a plus ib, it's 5 on 5 minus 12 on 5i, which is 1 minus 12 on 5i. And that's a much simpler form. So with division, you are multiplying by the complex conjugate. So just one more example. So let's just say we had z equals 4 minus 3i and w equals 1 plus 2i. So if you wanted to find z on w, that would be 4 minus 3i on 1 plus 2i. So you're going to multiply by the complex conjugate. So really what you're multiplying by is w bar. So you'll end up with z w bar on w bar. Okay, so on the bottom you get 1 minus 2i on 1 minus 2i. On the top you do top and bottom by the same thing. And then let's look at the bottom. So the bottom is the difference of two squares. So it's just going to be 1 squared minus 2i squared. And on the top you have 4 ones are 4 minus 8i minus 3i plus 2 threes are 6i squared. So 4 minus 11i minus 6 over 1 minus 4 times minus 1. 4 minus 6 is minus 2. Minus 2 minus 11i. 1 plus 4. Because the minus times the minus is a plus. So minus 2i minus 11i on 5. And if you put in the form of a plus ib, that would be minus 2 on 5 minus 11i on 5. Okay. All right, so what if we had 4 minus I on 1 plus I equals a plus ib, find a and b. Okay, so if we take this and we multiply by the complex conjugate on the bottom, so the difference of two squares, so the bottom would be, this is for the left-hand side, the bottom is 1 squared minus I squared. The top would be 4 ones are 4, minus 4i, minus I, and a minus times a minus is a plus I squared. So you get 4 minus 5i minus 1 over 1 minus minus 1. Because if you square I, you get minus 1. 4 minus 1 is 3. 3 minus 5i. 1 plus 1 is 2. So this is 3 on 2 minus 5i on 2. Okay, so now I've got it in the right form, and if I've got a plus bi or a plus ib, realise bi and ib are the same thing because it's multiplication. So it doesn't matter what order it's written in. So a equals 3 on 2 and b equals minus 5 on 2. Very similar to when you do surds and you equate, you find the a, the b, and do the rational and the irrational part.